Welcome to Own Your Heart Health. I'm Dr. Regina Druz, your holistic cardiologist. This week, we will dive into common heart health concerns, uncovering root causes, and unpacking scientific discoveries and controversies. The information provided does not constitute medical advice. Please contact your healthcare practitioner before making any changes that may impact your health. Welcome, everyone. Today, I'm super excited to have Ryan Smith, who is a co-founder of a very innovative, groundbreaking company called TruDiagnostic. TruDiagnostic is a company that is giving us an opportunity to understand biological aging. Yes, I know you have your driver license or your passport, and you know that, let's say, whatever age it shows that's the age you are. But actually, that is not entirely true, because your body and your biological systems are aging at different rates. And some of us are pretty much the same as our driver license age. Some of us are substantially younger, and some of us, unfortunately, are substantially older. So this is a very rapidly evolving area of research. And I let Ryan introduce himself. Ryan, tell us about yourself.
Yeah, thanks, Dr. Druz, for having me. I'm happy to be here. I am the co-founder of TruDiagnostic. We started TruDiagnostic right around July of 2020, so a little over 4 years old now. And really with the idea that we wanted to certainly quantify aging, but to do so with a really unique technology called DNA methylation. We lead this company and most of now the strategic research behind it.
Excellent. And so I just learned a few moments before we were coming onto this recording that you actually are not a PhD. You took a bit of a different route into it. So tell us about that route. What was happening?
Yeah, it was a long and winding road, to be honest. As an undergrad, I always wanted to be in medicine. So I was a biochemistry major, and knew I wanted to go to medical school. So after my undergrad, I went to the University of Kentucky for medical school. Went to my first 2 years. I passed my USMLE Step 1. But got to the third year where the clinical portion starts and just really didn't like it, to be honest. It was, I think, treating a lot of sick patients and, especially in this area of Kentucky, I didn't feel like I was helping a lot so much as just following and triaging patients. And so I decided to make a very stupid financial decision, which was to quit. And then a few months later, created a compounding pharmacy called Tailor-Made Compounding, and was really lucky enough in tailor-made compounding to have really good success. We were the fourth fastest growing company in healthcare. We went from me as the first employee to over 200 employees within 2.5 years. Pretty massive growth. But one of the things we were doing uniquely at tailor-made compounding was sort of doing a lot of unique peptides and proteins. So we built this whole category of really peptide medicine. But a lot of the things we were doing didn't have long-term safety data, long-term effect data. And so I was always looking for ways to validate what we were doing. And this sort of coincided with the, I would say, really unique and cool science of the epigenetic clocks, being able to predict outcomes like death very accurately. And so I got really, really excited about it. And so excited, in fact, that ended up selling that company in early 2020, right at the start of the pandemic, in order to create TruDiagnostic.
Okay, so let me backtrack here. So when medical students fail, they become groundbreaking entrepreneurs, right? So that's the lesson that I learned. And, being an entrepreneur myself, way later in life, I could still see, advantages and disadvantages. So talk to us, most of our listeners are general listeners. And actually, if you are listening to the show on your favorite podcasting platform, we do encourage you to listen to the show actually on YouTube, because I have a little bit surprise for you, and it's something that would be great for you to see on video, because it's so much easier to visualize than to talk. But what are DNA methylation clocks, and what has been the evolution of science with our understanding of health and longevity using DNA methylation?
Yeah, absolutely. So before I even get into DNA methylation clocks, I just want to stress the importance of this process of aging. I think when people hear about it, they might think of, things like aesthetics, like their skin appearance, or, some of these more vain applications. But what most
Sure.
people don't realize is that aging is the biggest risk factor for almost every chronic disease and death. And this is, the reason that we can have people with the same exact biomarkers at the age of 30 and the same exact biomarkers at the age of 60, but we can have disease presence and a much lower quality of life as people get older. And this is a major importance. If we're really wanting to do preventative medicine and fix the biggest risk factor, that biggest risk factor is this biological aging process. And so I think that hopefully sets the context of why it's so important. If we were just even to increase lifespan by 1 year in the world, it would save the U.S. Just the healthcare spending $67 trillion. And so you can imagine that this has massive impacts. And so with that being said, we've already identified that the difference between chronological and biological age is different. Most people know people in their 60s who look 50, and most people, vice versa, know probably people in their 50s who look 60, right? And this is because we don't all age the same in our bodies, right? And defining aging just as an arbitrary, how many times we've been around the sun, is not indicative of our biological physical function. And so the search for this has been going on for a long time, even before the epigenetic clocks came out. But really in 2013, there was a huge breakthrough from Steve Horvath at UCLA, he was able to create a clock that could accurately predict the chronological age of a person from any tissue. And this was a really, really big breakthrough because they thought maybe now we can molecularly measure a process that we really want to quantify.
So this is so important because I emphasize it with my patients all the time. We often get patients at holistic heart centers who are troubled by the fact that we find
Mhm.
signs of aging in their cardiovascular system. And in one of
Mhm.
my earlier episodes, I talk about coronary artery calcium score, and we sort of just
Mhm.
began to scratch the surface of this topic. But I always try to impact on my patients is that while you may look great on the outside, and we all want to look great on the outside, and you may even have optimal body composition and eat healthy and exercise, it's truly the internal measurements of aging which tells us the full story. And one of the
Mhm.
things available to us right now is a surrogate marker. And that surrogate marker, of course, is a calcium score or the
Mhm.
overall burden of atherosclerotic plaques that we may be detecting, for example, in the carotid arteries or heart
Mhm.
arteries or any other arterial system of the body. And looking at this, we have seen that there is definitely an escalation of coronary artery calcium in middle age. There are a lot of reports on
Mhm.
asymptomatic individuals. But here with Ryan, we're diving actually much deeper. So let's
Mhm.
talk about, Steve Horvath and his clock
Yeah.
and what actually is DNA methylation. Because maybe,
Yeah.
let's define what
Mhm.
DNA methylation is.
Yeah, definitely. The generally most people know about genetics, right? These are the genomic sequence that makes you you. It's unique to you. It's very, very specific, but it's also the same in every cell throughout your body, right? Your skin and your heart and your brain all have that same DNA sequence. But obviously, those tissues behave very differently. Your heart is behaving like a heart, and your skin is behaving like skin. And so how do they behave so differently if they have the same genomic instructions? And the answer is by what DNA is actually turned on and expressed versus what is turned off. And this process is mitigated through epigenetics, as we call it, or above the genome. These changes which affect how our genes are actually being expressed and turned on and turned off. And so there's a lot of different epigenetic changes, but DNA methylation is one of the most common. And it really is the off switch of a particular gene. So the more your methylation is attached to a certain gene, that means generally it's not being transcribed to RNA, which is sort of how our body carries out that function. So we're looking at the off switches of this DNA. And this is what I think everyone was so surprised about in 2013 was so accurate at predicting the age of an individual.
Hi, everyone. It's Dr. Regina here. I know there are contradictory opinions about nutrition for heart health and longevity. Discussion often gets heated and confusing. There are those who push for low fat, low cholesterol. Then there are fans of a ketogenic diet. There are many anti-meat voices as well, suggesting vegan or vegetarian style of eating. With all the chatter out there on what and how to eat, my team and I decided to create a tool for patients, medical professionals to clear the clutter It's called Holistic Heart University, and it provides on-demand courses, nutrition and lifestyle resources, information on supplements to make it easier to understand how to make healthy choices for your heart. I'm especially proud of our open office hours for program patients and the Q&A feature where you get to ask your individual questions and put us in the hot seat. Head out to the show notes for the link and use my special promo code to get a huge 20% off on our annual health and wellness subscription. The code is owner20, and I'll see you in the office hours. And so the Horvath clock was one of those first generation DNA methylation clocks, right? It looked at the patterns of methyl groups. There are specific methyl groups. We can think of them as little molecular groups that are added in strategic places on a person's DNA. And actually, the epigenetics as a science is fascinating because this is how we discovered how impactful methylation is, right? There was something called a Goody mice experiment that was absolutely groundbreaking in figuring out the methylation patterns and what methylation actually means, where mice that were deficient in methylation were overgrown and have a sort of big and fat and didn't live long enough, and mice that were fed a diet rich in nutrients that assisted methylation were lean and agile and not as susceptible to early death. So this is sort of extension of this concept in humans. So take us through, after Steve Horvath launched his clock, what happened thereafter?
Yeah, so generally, when Steve first launched his clock, it wasn't used as a health tool first and foremost. It was used as a tool for things like forensics to see how old someone was if they left DNA at a crime scene. It was used, notably in the Syrian refugee crisis as well, where there were a lot of refugees coming into Europe, and European agencies were using this test to tell if they were adults or minors, and then therefore eligible for asylum. So it had practical application, but it wasn't used as a health tool until it started to be run in big biobank cohorts, like the Framingham Heart Study. And then they saw some really unique patterns. And what they found is that those people who were younger than their chronological age with this testing were protected from negative outcomes. And those people who were older than within their chronological age with this testing were more at risk for all of these negative outcomes. And this is exactly what they would have expected to see. But what it tells us is it wasn't just capturing chronological age. It was actually capturing a biological signal that was predictive of health outcomes. And that matches up with what we know about aging being the biggest risk factor for every chronic disease. And so that was really exciting to see that this wasn't just a chronological age predictor. It was actually capturing health specific information that could predict outcomes. And so that was super, super exciting. But the problem is that the better those clocks got at training to chronological age, the closer they just got to telling you your birthday, right? So there needed to be a change in this philosophy. And so that change happened right around 2017, 2018, also through Steve Horvath in his lab, particularly with a student at that time, Morgan Levine, who started to train these to biological phenotypes. So instead of just looking at your age, they were looking at how your blood-based biomarkers change over time as we get older, and turn that into a clock that was predictive. And that was a big step in the right direction. Those are what we call second-generation clocks trained to predict biological phenotypes of aging. And they were even more effective at predicting outcomes than those first generation clocks. And so that was probably one of the biggest developments in the clock advancements.
So let us circle back on this, because in precision cardiovascular medicine, right, we're rapidly expanding in precision cardiovascular medicine, and there's been great publications in that arena. And actually, American Heart Association meeting just wrapped up in Chicago. And so there's some really interesting paradigms that are emerging from that. So this concept of relating the phenotype, which are just external characteristics, to what's happening on the inside, we actually recognize this as endophenotype. And this is, fancy word. Endo means internal, phenotype means what things look like. What does the inside look like versus what we see on the outside? That's just the simple way to think about it. And so there was the beginning of bridging the gap. So what was the outcome of that after looking at these databases such as Framingham Heart Study and I believe also UK Biobank? What resulted from that?
Yeah, so generally, what we saw is that these clocks were able to predict risk, and not just that, they were able to associate to health patterns, which could tell us if a pattern of behavior is actually helpful or harmful. Right? They can actually be surrogates for measuring the biggest risk, and then also telling us what's effective at reducing that risk, which is really the exciting part, and how they can actually be used in a clinical basis. We can actually start to say these things are good or these things are bad, and so this is the really exciting part, is that in the early years, they found a lot of associations that were probably not too surprising, right? We see that exercise generally is going to help you with your aging. Smoking and drinking, extremely negative for your aging. We saw the different diet patterns, things like Mediterranean diets be helpful for aging. But we started to get this information in a really clear and concise way, which is that these clocks were predictive of outcomes. If you were aging higher on these clocks, it's a negative thing. But then we could start to look at what behaviors are associated with higher or lower aging rates. And so now we can actually quantify what's effective for aging strategies. And that was a huge, huge breakthrough.
Yeah, absolutely. So a lot of, I think, individuals who are interested in health optimization, especially with optimization that affects their longevity, and for many middle-aged adults or even adults after the age of 65, longevity optimization is probably the number one priority. So the prior efforts were focused primarily on telomere length. So can you comment, first of all, what is telomere length, and what is the difference between telomere length and the biological, second generation biological aging clocks that do give us those endophenotypes that, and we will be seeing endophenotypes in a few moments. It'll be my endophenotype. So, the world or whoever is listening will actually look at my biological aging profile and, make their own conclusions. But let's talk about, telomere shortening, what is it and how is it different from those biological age clocks?
Yeah. So generally, whenever people were looking for these age biomarkers before we had these clocks, all we could really look at were how our regular biomarkers change over time, right? So one of the biomarkers that is most correlated to age is telomere length. So telomeres are sort of the very ends of our DNA, and they're created biologically because of a really special thing that happens as we replicate cells. So as most people know, our cells are growing and replicating every day. Every 7 years, we have completely different cells in our body than the 7 years previous. It's sort of like a ship of Theseus type of analysis. But this process is happening all the time. But unfortunately, there's one thing that happens in our cells, which is that we unfortunately can't replicate all of our DNA. We tend to lose a few bits of base pairs every replication we go through. But the good news is our body has planned for this. It includes DNA at the very ends of our DNA, which are actually called telomeres. Those are what these telomeres are called. And they're programmed to generally be long enough so that our cells can replicate throughout time and not be harmful to us.
So it's our insurance policy, right? It's important to think of it. It's a little bit of an insurance policy because we want to tap into this reserve, into this insurance as we get older.
Exactly. And so because this happens with our cellular replication, and our cellular replication happens at frequent intervals, what we can actually look at is the length of those telomeres are very highly correlated to age. And so generally, there's been over 20,000 studies published on telomere length and aging-related outcomes. And so it's been a classical biomarker of aging for a long time. It even, the science and identification of telomere length won a Nobel Prize, and was done through some great researchers in Spain. But in recent years, we've started to find that this is actually not the best biomarker of age. So while it's extremely correlated to age, it actually isn't predictive of health outcomes. And that's one of the things we're using this for. If we're going to test you, we want the test to tell us important information so that we can guide clinical treatment. We don't just want to test you for something that we won't use, right? Or won't be applicable.
So that's super important, right? Because in science in general, we always emphasize that correlation is not causation, right?
Mm-hmm.
And this is, when we see a correlation, it doesn't necessarily mean that one thing causes the other. And, and the famous example that I read that brings it out full force is that if you were to look at satellite imagery at the area where there's a fire, for example, forest fire, and you will see a lot of firemen and fire vehicles in the area, well, that's just correlation because the fire vehicles didn't really cause the fire, right? They're there to address the fire. Something else had caused the fire. So correlation is not causation. And so do these second generation biological clocks give us more of a prediction opportunity as to A, what is happening right now, and B, what can we do to reverse some of these negative biological changes and optimize our longevity and our cellular health?
Yeah, absolutely. And so I'll just to compare them head to head, Riccardo Marioni from the Generation Scotland cohort did a comparison. He said, how predictive is telomere length of the many different phenotypes of aging? And he found that it affects right around 2.8% of the variance. And even those first generation clocks, just the clocks that we now have sort of moved on from and don't use much anymore, those explain over 28%. So over 10 times the amount of explanation and predictive capability. The newest clocks explain over 60%. So as we're looking at which one we want to do we want something that predicts 2.8% or 60%? We're going to want the one that's way more predictive. And that's not to say telomere length is not something that we should think about as a scientific topic. It's just that currently the clocks are more clinically useful than telomere length.
Interesting. So tell us about kind of the current generation of the clocks, because let's lift the mystery for our audience. And if right now, if you're at this point in the podcast, this is where you go into the YouTube, because what you will see is my report. Granted, I got it, a couple of years back. Ryan is going to tell me you should be retesting yourself every 3 months, but so I will try. I'm making a resolution for 2025. But just as we're about to end yet another circle around the sun, let's listen and understand what are the current generation clocks and what kind of parameters they tell us.
Certainly. And so I really want to focus on two different types of the newest clocks, which are the most exciting. The first one is what we call the third generation clocks. So a little bit beyond those second generation clocks, but very similar. They're also trained to biological phenotypes. The only difference is that the algorithms are trained in the same individuals across time instead of a lot of individuals all together. And so by looking at an individual's sort of longitudinal journey, we can get much clearer signals of what happens as we age. And so that clock, which was created, it's called the DunedinPACE, and it gives you a pace of aging. So it doesn't give you an age. It gives you how fast you're aging right at this moment. And that can be really helpful sometimes because it's more responsive to change. So if we're going to do short-term interventions to see what works for us, the DunedinPACE is one of the most responsive clocks. And it's also generally one of the most correlated to quality of life as well. So I know that people might be listening to this and they might be thinking, I saw my grandmother live to 98 and I saw the last few years of that quality of life and I wouldn't want to be there myself. I really want to focus on, how good my quality of life is. And the first thing I always tell people when they say that is that health span and lifespan are absolutely correlated. If you're improving your quality of life, generally you're also improving the length of your life. And so it's not mutually exclusive. You don't have to choose one or the other. But what we see though is with these clocks, we can optimize both. So one of my favorite things about the DunedinPACE of aging is it's correlated to things like facial aging. It's correlated, so even how you look, right, but also it's correlated to mental processing speeds and IQ, all of these great things. So that's a third generation clock, and one of the results we'll look at here today. The other category of clocks that I think is super exciting is the newest version of what we call Gen X clocks, or generation explainable clocks. Because one of the big problems with the early clocks is we could tell you if you're older, we could tell you if you're younger, but what do you do about that, right? That's one of the important things.
Exactly.
Is that and so if we, for instance, saw that you were aging really fast with your pace of aging versus aging really slow, most of our recommendations are going to be the same for you regardless, right? Because the things that we know work for aging generally work for everyone in aging. And so how do we make it a more personalized? And so two clocks have come out that we helped develop, one with Yale, which is called SYMPHONYAge. The other is with Harvard called omic-age. And these include not just the clock ages, but also information on the how and why you're aging. So in the SYMPHONYAge clock, we're able to tell you the age of 11 different organ systems. So we can see which one is aging fastest. And with the omic-age, we can actually predict blood-based biomarkers with really, really high accuracy to tell you what is out of range and what is probably increasing your aging versus decreasing your aging. And so these new clocks.
I have to tell you, and I'm sorry to interrupt. When I took this test, I was blown away, right? It's absolutely mind-blowing information. It was a little finger prick, with a few drops of my blood. And then I had this profound report. And I think at this point at the Holistic Heart Centers, we are probably close to 75 patients or so who have gone through the first phase of our Fit New Genes program. And we are aiming, of course, to optimize not just cardiovascular outcomes, but also longevity outcomes. So we are approaching that second phase where we will be retesting them to see actually where they ended up. And so the omic-age report and the SYMPHONY-age reports are just groundbreaking type of a report. So let's do this. Let us jump into my report so that Ryan here, we'll talk it through so that we can see, where I can do better, because we always want to do better, and this is where I want to do better. Let me just figure out exactly which place I want us to go on, and we will go right into it. So this is my report, ladies and gentlemen. So if you're here listening to this, this is where you want to watch the video. And so I have, at the time when I did my test, I was still in the exploratory phase of it. So I was 54 years old. And this was my omic-age result. So what does it mean?
So first and foremost, generally risk is going to be zero, relative risk at this when your biological age is the same as your chronological age. And so if you go above that, you're increasing your risk of every negative disease outcome. And if you're below that, you're decreasing your risk of every negative disease outcome. And so this is a phenomenal score. This is something we don't see very often. And so quite frankly, this is in the top 14% of people that we would test. And I should mention,
absolutely, here it is.
Okay. Exactly. And so this is a really good score. And you get those smiley faces on there, but let's talk about what it actually means, which is that the relative risk of almost every disease outcome is going to be significantly lower. So for instance, with a score like this, you're talking about a 35% decreased risk of death compared to other people of your same chronological age. That is a huge, I would say, decrease. One of the other things I should mention is that this algorithm is actually the most predictive of time until death. So we can actually predict death with a 92% accuracy within a 5-year or a 10-year time period with this algorithm. It is incredibly effective at predicting lifespan. And so the lower this is, the longer your lifespan is actually going to be. And so this is a really, really good score that first and foremost tells you you're in the right spot.
Right. So this was explained to our listeners because this is sometimes a difficult point to transmit in patient consultation. What was I and people like me who have this test, who were we being compared with?
Yeah. So that's important. In this one, we're talking about the 14%. We like to compare to the group that we created this algorithm with. And that group is the Harvard population cohort. So anyone who comes to Mass General Brigham, one of the best hospitals in the world, is going to be included into this group that we selected. So that is an amazing score. I should mention that if you're comparing to our population, it becomes a lot more competitive because most of our population are people who are very, very healthy and optimizing every bit of their lifestyle in a preventative medicine fashion. And so our comparisons are sometimes a little bit more difficult.
So I will fail a little bit if the comparison is done with your population, but I did well versus the Harvard population. Am I reading you correctly?
Correct. And the Harvard population is much more indicative of the general population, everyone that you would see in the entire world. Our cohort is very, very optimized.
Okay, so I'm heartened to know that I actually have done better than 85 or 86% of the general
Mhm.
population, and certainly one can compare results over time. Now let's talk about the SYMPHONYAge and what does that
Yeah.
mean?
So SymphonyAge is an algorithm we created with Yale, and it is one that's able to provide a breakdown into all of the ages of each organ system. So we do 11 different organ systems, everything from your lungs to your liver to inflammation, et cetera. And so what we find here is that unfortunately, this one's a little bit different than what we saw with
Mm-hmm.
Omegage. We're seeing just a little bit of an acceleration here. And we can actually then go into the resolution of that. So we're seeing a little bit of an aging signal, not much of one, right? Barely, not even a year, essentially, right? But with that being said, we want to know why. And so this is when
But
we're
we
going to,
also know,
yeah.
Ryan, so before we go into why, because there was been some very interesting recent literature that sort of defined,
Mm-hmm.
two ages, which are threshold acceleration ages, right? I believe
Mm-hmm.
it was 45 and 60. So
Correct.
this was one of the recent studies. And I think
Mm-hmm.
for individuals, it could be a little bit different. You're not necessarily
Mm-hmm.
programmed to accelerate at 60. You can accelerate at 54 and 55 and, whatever
Mm-hmm.
leads to 60. So
Mm-hmm.
here's the opportunity for us to drill down into the organs and see what is leading this acceleration, correct?
Exactly. Because again, we don't just want to see this information. We want to do something about it, right? And so generally we want to make our efforts in the place that's going to make the most difference. And so where we really want to see right now is, what is the highest, right? And also what's the lowest? Where am I doing good? And where do I need to maybe pay a little bit more attention?
So this was a surprise to me
Mm-hmm.
because I fully expected that
Mm-hmm.
inflammation, metabolic, and hormones will surface to the top. But instead, what surfaced to the top was this: musculoskeletal, immune, kidneys, and the heart.
Mhm. Yeah, exactly. And there's some other ways to sort of visualize that as well. And if we do, we can sort of see those relative comparisons. So it looks like that your brain age, your hormone age, your blood age, all of those were phenomenal. And even your lung and metabolic and inflammatory ages were still younger. But where we're seeing by far the biggest increases are particularly in the heart and in the immune system. And so we might want to focus there first for optimal aging interventions.
And I have to tell you that
Mhm.
this is so profound
Mhm.
because in several years that followed this, I have noticed certain cardiovascular changes,
Mhm.
specifically elevated blood pressure. I'm not hypertensive, but I
Mhm.
do have periods of elevated blood pressure that I'm actively working to reduce. And I think the immune system functionality, and we'll talk about it in a separate
Mhm.
episode, but this I should have taken this advice closer to heart because, as
Mhm.
you know, immune system is very powerful at preventing
Mhm.
a lot of chronic diseases, including things that are related to for example, malignancies, dementias, and so on and so forth. So this is
Yeah.
very impactful part of
Yeah.
information here. So
Yeah.
how often would you say an individual should be repeating those clocks? We have two of
Yeah.
them. So omecam-age and SYMPHONYAge. Is 3 months enough if they're doing really focused, concerted
Mhm.
effort to change? It did spur me to finally
Mhm.
begin doing weightlifting. So I
Yeah.
finally
Yeah.
listened to advice that had
Mhm.
been given and start improving my muscle mass. But how often should a person who is interested in
Yeah.
improvement be resampling to see if they are on the right track?
Yeah, so I generally will answer that question differently according to what people are trying to do about it, right? I think that one of the great things about this is that it reduces some of this guesswork, right? We don't need to, for instance, now it can be a personalized medicine intervention. So if you're changing things rapidly, I would recommend more retesting. But if you're trying to focus on known and true initiatives and trying to measure sort of how they're actually working with you, I generally say once or twice a year is plenty. It can give you an idea of what direction you're going, and then give you feedback on what's working or what's not. But if you're one of those people who likes to biohack, likes to be absolutely optimized with all the best supplements, all of the best medications and lifestyle interventions, then I might recommend doing it a little bit more frequently to actually see if this is working for you or if it's maybe something that should be lower prioritized.
Hi, everyone. It's Dr. Regina here. Many of my colleagues and I are noticing patients coming to us with self-ordered blood tests. When this trend started to gain momentum, I thought it would benefit many patients. After all, who doesn't want more access to health testing? However, I see that self-ordered labs often lead to more confusion and frustration for our patients. Patients are coming in with a pile of labs, and sadly, they're not better off for it. This is why we at Holistic Heart Centers have launched Heartwell Toolkits, a curated collection of blood and genetic markers that one can get at home, focused on heart and brain health, gives you all the data you need to make informed and actionable health decisions. The toolkits can be ordered at our shop on holisticheartcenters.com. You can find the link in the show notes. Use the code TESTING10 to get 10% off and free shipping. So we typically, in my practice, in our Fit New Genes program that gives patients access to this type of testing, we typically retest once a year because we do want a lot of this optimization to take place so that we could look at the interventions and say, well, were these interventions actionable and resulted in a favorable outcome? Or is there some other areas where we have to lead it? So now we're going to come to, you mentioned DunedinPACE of aging. So what does this one mean?
So this one is, again, I just want to reiterate, one of my favorite algorithms. This one was created with Duke, and it tells you how fast you're aging right now. So in a single point in time. So, when we're looking at those other ages, they're encompassing your entire life history, right? And so some people might have had, really hard lives even growing up, right? We even see that adverse childhood experiences correlate to the level of aging even in our adulthood. Whereas the DunedinPACE is much more likely to change quickly. It's meant to be a sort of a snapshot in time of how well you're doing right now. And so it's reported on a biological year per year basis. So what we're seeing on this result is that you're aging 0.99 years biologically for every one chronological year, which is about equivalent, right? But the good news is you're not above one, because if we see you above one, that dramatically increases your risk of disease. And so, yes, exactly. These are the statistics I always go into, which is that generally there's a 56% increased risk of death if you're over one, and a 54% increased risk of a chronic disease diagnosis in the next 7 years if you are above one. So we want to keep this below one. That is a huge priority.
So this is actually interesting because it samples your aging rate, right? How fast you age at this particular moment in time versus the SYMPHONYAge and the age, which are essentially a reflection of everything that happened over time, correct?
Correct. And so sometimes they're going to be different, right? You might see, and I liken that we see this a lot in ER physicians who have, had poor sleep schedules, maybe poor nutrition. Then they get into this integrative functional medicine space. They improve their lives. Their overall ages might not be great, but we see their DunedinPACEs start to go down because they're headed in the right direction. So it's important to know what type of picture you're looking at, right? In terms of judging what's actually working.
So how much of, because it's based on what I'm learning and based on our discussion even today, I'm inclined to think that while the age clocks and SYMPHONYAge are better off sampled once a year, DunedinPACE is actually something that could be sampled, let's say, into 3 months of lifestyle effort, or 6 months of lifestyle effort, just to kind of connect the dots. So how much of a change here is actually actionable? Let's say if I resample myself and I end up at 0.98 or 0.97, is this an actionable information, or do I need to be more like 0.8 in order to say, hey, I'm aging less slowly than the chronological, than the length of time?
Yeah, it's a great question. And so, you're absolutely right. I want to first just mention a study that we did. And for anyone who has Netflix, it's actually a study that was on Netflix on vegan versus omnivore diets, where we took two pairs of a pair of twins, right? And we put one twin on a vegan diet for 8 weeks. We put the other one on a more standard omnivore American diet. And we tracked what happened in 8 weeks. And what we saw was that the rate of aging significantly decreased in the vegan diet versus that omnivore diet. So even in 8 weeks, we can tell significant differences in this. But what is a significant difference is another great question. And so generally, we answer this by sort of the technical precision of these clocks. And this is people always ask how accurate are these clocks, and this is a couple of different ways to answer that. One, though, is about if we measure the same sample you have multiple times, how much error is that? How different is it across the multiple tests? The answer is that for the DunedinPACE, it's about a 3.5% rate of error. So if we're going to say that, then basically what would make a true biological change is anything over basically 0.035, right? So if you were to go down,
or maybe is it a
yeah,
double of that? Like, is it more like 0.7, right? Because if it's your standard deviation is 3.5%, then probably two standard deviations in each direction would be in significant.
Exactly. So basically, if we want to be extra careful, 4 lower or 4 higher, right? Would be the idea. So if we saw you come back at 0.95, then we'd be fairly certain that you've done something pretty good for yourself.
Good.
Yeah, to sort of go in that direction. And so what we call those interclass correlation values, and this is actually historically been a problem of the epigenetic clocks, but now it has been corrected. So even the early clocks, actually for Dr. Horvath's clock, had an absolute error of around 4 to 5 years, which could be real. If you're testing within a period of 4 to 5 years, how do you know if that's a true signal or not? But now these are incredibly precise clocks. Even SYMPHONYAge and OMICAge, for instance, have less than a 2% error on those different draws, and are incredibly precise.
Fascinating. So this is really, I feel like this had opened a totally new chapter in how I approach patients that we work with at the holistic heart centers, because we are very data driven and we optimize metabolic health. We use a lot of digital biomarkers following various patterns, for example, stress patterns, sleep patterns, body composition, of course, heart rate and blood pressure curves, as well as metabolic health parameters. And now we're in a position to actually see how the interventions that we personalize, and those are very structured interventions for the patients in those programs, how do they actually impact the most important thing, which is longevity, and they could impact it short term, but we hope that with time, the impact is also long term, and the OMICAge and the Symphony clocks are actually reversing themselves in a positive direction, because we sort of all want to be like Benjamin Button, right? We want to age backwards. So Ryan, you have currently a new test which I have not sampled yet. Why don't you tell me a little bit about it so that we can understand it better? It's an addition to the current testing menu, and the current testing menu, essentially the report that you're seeing here. So that was my report, and I got a little bit of a pass, but still work to do. But what are the new tests, and what are they about?
Yeah, so we report out on a lot of things. Even in addition to those ages, we do things like telomere length. We can tell you fitness biomarkers. We can tell you how much you've smoked and drank across an entire lifetime. That's all part of that TruAge testing. But our new test is really, really exciting. And what we're actually doing is we're actually telling you about your micronutrient levels. We're telling you about things like all of your B vitamin levels, your vitamins A, D, E, K. We're telling you about all of your amino acids, but also some really other exciting things as well. So for instance, many people in the aging space might be familiar with NAD biomarkers. Now we can sort of quantify a lot of those as well, and have some really fun data that we'll be showing here pretty soon. But we can also quantify environmental exposures. So for instance, we can quantify your PFAS chemicals, some of those forever chemicals that you might expose. We have predictors of lead exposure. We have predictors of pesticides like glyphosate. We can also, though, do supplement levels. So we can tell you about other important nutritional products like your generally your alpha ketoglutarate or your creatine, but also our cardiovascular panel is pretty amazing. We'll be able to do your ApoB, your ApoA, your polyunsaturated fatty acid percentages, your monounsaturated fatty acid percentages. We'll be able to tell you your glycoprotein acetyls. We'll do a lot in the lipid panels as well.
I'm really excited because in 2025, this is the upgraded test that holistic heart centers will run. So this is super exciting. But from a patient perspective, is it the same as your other tests? Is it still from a finger stick drop of blood? And so are these actually direct measurements of these markers?
Yeah, that's a great question. And the answer is no. We're still measuring DNA methylation, but we're
Okay.
using DNA methylation to predict all of these other outcomes. And this is probably the most exciting thing. And the reason we're so excited about this new test is that to actually develop these algorithms, we actually had to measure directly the things that we're
Mm-hmm.
looking at. And we also had to measure DNA methylation. And then we created these algorithms and then we test them, right? We test them against the data that we've never seen before to say, hey, are we effective at predicting these values? And the answer is we're certainly effective. We see the same associations to disease of the regular biomarkers, which is a good first step. The next step we ask is, can we see longitudinal change with interventions that we should see longitudinal change with? And the answer there is also yes. But the surprising thing, and the thing that I think gets us the most excited, is that we actually saw in 64% of the time, our biomarkers were actually better than the classical measured blood-based biomarkers. So I'll give you an example. So systolic blood pressure, right? We talked about it as a
Mm-hmm.
cardiovascular risk
Yep.
factor. It is measured almost every time you go to the physicians, right? And generally for cardiovascular disease, our prediction of systolic blood pressure is twice as predictive of cardiovascular disease as regular systolic blood pressure. And so what we sort of have found is that methylation is sometimes in 64% of the time better than what's actually being measured in your clinical labs. And the reason we think for this is because we're getting a bigger overall picture. So I'll use the example of fasting glucose versus HbA1c.
Mm-hmm.
Fasting glucose can vary frequently, right? Depending on what you ate.
Dramatically. Yes, of
Yeah,
course. Of
yeah.
course.
That's why they recommend you take these labs fasted generally in the morning. But the thing about the HbA1c is it's almost like a 3-month running average of the
Mm-hmm.
amount of glucose in your body. And that's sort of what we're seeing here with methylation is that we're getting a longer average estimate of a biomarker, which is more indicative of the holistic picture of your health. And that's why generally we're predicting outcomes better than the actual classical surrogate.
So,
And
by the
that's why we're excited.
outcomes, are you,
Mhm.
for cardiovascular, for example, when we run
Mhm.
through so-called pooled cohort estimate equations, or I very
Mhm.
often do multi-ethnic study of atherosclerosis
Mhm.
because our patients have coronary artery calcium scores, or we get the coronary artery calcium scores. There's a new algorithm now called Prevent, which is
Mhm.
really trying to link cardiometabolic renal things together. It's been criticized because since American Heart Association released it, it seemed to have risked a certain group of patients that by other estimates were in a higher risk bin. So
Mhm.
these are for heart events, which is non-fatal MI, cardiac
Mhm.
death, and sometimes total mortality. So are these the outcomes that the methylation pattern is able to predict with greater accuracy?
Yeah, and so that's the beauty of it is it's across disease, whether or not we're talking about, coronary artery disease or cardiovascular disease or stroke or congestive heart failure, ours generally perform better than all of them, but not just heart specific diseases. We also have COPD. We have even depression. We have a lot of these things and across all of the diseases, 64% are actually better. But I will tell you for cardiovascular disease specifically, 92% are better. And
I wouldn't
so
expect any less. It should be
yeah.
95 or higher because the most impactful disease of our lifetime is cardiovascular. I always tell my patients, say, "Oh, doc, my muscles, my nerves," and I said, "Listen, I heard this saying from another practitioner who said." Muscle is the currency of aging. And I tell my patients, muscle is the currency of aging, but it's your cardiovascular system that sets the interest rate. And so you and you
I
have
like
to
that.
understand what those interest rates actually are. So very interesting. So
Yeah.
what would be then, as we're about to go into the closing stretch, what is your advice? For example,
Yeah.
and I'm super excited to bring this test to myself and to my patients because, it just came out and I'm thrilled to see the amount of information. So would you say that starting with this more comprehensive test, plus the blood-based biomarkers, and maybe
Yeah.
sampling DunedinPACE, depending on the degree of effort and length of the program, and then resampling at a 1-year mark. Would that be a reasonable pathway?
Absolutely. And I think you explained everything there perfectly, which algorithms we could do a little bit more frequently if we wanted, based on
Yeah,
what behaviors are doing more frequently if you
right.
wanted. So I think you summarized it really well. I do want to mention just, I think the reason that we're generally excited is because, let's just use cardiovascular disease as an example. Some of the ways you would get a calcium score or a cardiac cath or, these CTs, they're expensive and they're oftentimes invasive. And the great thing about
Yeah,
DNA methylation is that we can all do this where we can quantify a lot of that risk with a single blood-based biomarker. One of my favorite recent studies is they've actually created just a methylation risk score for cardiovascular disease with methylation. And their area under the curve for predicting it is 94% and you can do that with the same data we're getting for biological age and all of the other outputs we're getting. And so really it's sort of our vision in the future. Again, aging has always been our major focus because of its relative degree of risk. But now that we're finding so much information in these epigenetic signatures, they can be applied to a lot of different things at a really low cost. And so hopefully we can, start to launch even more data analysis from this data set and then avoid expensive and sometimes invasive options.
amazing. So would that data set then actually report a cardiac age because of such a high correlation? Would that be in the report? Let's say your cardiac age is X, because I can tell you the beginning of my career was in cardiac imaging, and I'm still cardiac imager at heart, pun intended, because I love cardiac imaging. And I learned over time, for example, reading echocardiograms, that I could almost predict the decade of life based on the echocardiogram, because the heart changes in terms of its shape as we age.
Excellent.
There's so-called uncoiling of the aorta, and things shift a little bit to the right. So, so you could see actually the aging process as it transpires in the structure of the myocardium. So will there be a cardiac age on the report?
Eventually, yes, and
Eventually.
not right now, but definitely, we'll have another new report coming out by the end of February, which will actually be a methylation risk score, which will tell you your risk of cardiovascular disease, it will tell you your risk of coronary artery disease, and it will tell you your risk of stroke. And so we will have those three, and all of those area under the curves are 0.85 or better, so 85% of people adequately diagnosed or better. Again, with the same data we're using to generate your biological age.
Amazing. So, and this new report, is it something that you guys provided your own, or is it again in conjunction with a research institution?
So this new report is all on our own, but we published this new data with Harvard, and so our Harvard collaborators, the same ones we created with omic-age, we generally there created such a robust data set that we're going to go back to that data set again
and mine it again.
Really,
yes.
with really novel inventions.
Could you comment, recently there was a publication, I think it was also a collaboration between your company and academic institutions, that sort of said, what are the things that actually work to, give us a better profile on our aging clocks, to improve our DunedinPACE? What are the things that, based on this massive area of investigation, that are actually working?
Yeah. So we did publish this just recently with Yale, where we looked at 51 different aging interventions, and we basically studied them over time to see what was the best for aging and what was the worst. And I want to mention something here, which is that we used every clock that's ever been published in that analysis. We probably wouldn't want to do that if we're talking about clinical. We probably would only want to use the clocks that are the most predictive, right? So in this one of the things that happened as a result of this publication is that I think people, tweeted out some things like, exercise doesn't work. And that's not necessarily the case.
Not true.
Yeah.
Right?
And so we don't want to over extrapolate, because we included, we really wanted to show what clocks are the most responsive, what types of interventions are the most responsive. And so what we found were some really interesting things. Number one of which, it's a lot easier to reverse aging in people who are not doing as well. So this is also, I think, a positive thing, because, don't be scared of this testing. If you're taking this testing,
take control, and because there are things you can do.
Exactly. And so that was one of the first findings. But the other big findings is that which clocks were actually the most responsive. And the good news is that the four most responsive clocks are the ones we've already talked about: SYMPHONYAge, DunedinPACE, omic-age, and then lastly, GrimAge. GrimAge by Steve Horvath, his time until death predictor as well, was super responsive. But we also, generally found some other exciting things. So we found some, less exciting things that we already knew, right? Which is that generally, again, exercise responds to that. Healthier diets like Mediterranean diets generally do very, very well. But we also find some things that were really unique and novel. And that is, for instance, that, things like hyperbaric oxygen treatment are really good at reversing aging. Actually, the top 3 interventions were all based in HIV cohorts. So that's a very different population than healthier people. But the best intervention for people who are already healthy was hyperbaric. And we saw reductions in DunedinPACE there. And it had a really good significance. Outside of that, we, generally also found things like senolytics in some cases, actually are effective at, senescence is a process that happens with aging.
Like metformin, did metformin made the cut?
Well, metformin lit up the board, actually one of the top interventions, but I will mention that was, again, also an HIV population. So you would expect it to be a little bit better in that population. And so that's why we also say don't overinterpret the results, because some of these studies are happening in patients who are very, very healthy, or in much more diseased populations. Some might be 8-week interventions. Others might be 2-year interventions. So you can't always compare apples to apples. But what we did find is that these clocks, particularly these newer clocks, are very effective at being able to measure change. And particularly even with some things like the SYMPHONYAge clocks, they made a lot of sense. So what we saw, for instance, is if you stop smoking, we saw your lung age go down. We saw your heart age go down. We saw your inflammatory age go down, all of which makes perfect sense. If we were doing kidney transplant or kidney dialysis, we saw your kidney age improve, for instance. And so we saw that these new generation explainable clocks change in the way that we would expect and in the systems that we would expect, which is good because it means that we're getting very clear signals for each of those organ systems.
So this is fantastic because, patients very often ask, how do I know that these interventions will be effective for me? And so in addition, for example, for things that we routinely do, biometrics, digital biomarkers, blood markers, which are fairly easy to sample, we can actually see if those interventions are effective on a much larger scale with regard to the overall age, pace of aging, and even organ aging, because that's really that translational opportunity that connects the dots. Absolutely fascinating. I learned a ton. I am looking forward to getting my kit and, seeing this extraordinary amount of information. Hopefully I'm still the top 14%, maybe not. I don't know. So, so stay tuned for that. And Ryan, thank you so much for being with us today. Now to our listeners, if you want to learn more about this type of testing and in general, what kind of testing we're offering at the Holistic Heart Centers, we do have Holistic Heart University. You probably are going to hear an ad for it, and I'll put it at the show notes because we routinely discuss these topics in our Holistic Heart University. We have programs for individuals who are interested in heart health and optimization, as well as programs for professionals and our patients. Ryan, thank you so much for being with us this morning.
Yeah, it's a pleasure. Thank you for having me, and look forward to going over your next results.
You got it. Take care. Bye-bye. Hi to all professionals listening to us today. If you're thinking of launching a cardiometabolic or integrative cardiology program in your practice, we can help. At the Holistic Heart Centers, we help docs in practice to expand into hybrid or concierge services. Head out to the show notes and click on the application link. Your intro call is entirely free. Ready to schedule a practice review? Use code DOC10 for 10% off our Practice Power Hour 16 minutes coaching session. The link is in the show notes. Thank you for tuning in to Own Your Heart Health with Dr. Regina Druz. This podcast is powered by Holistic Heart Centers. If you enjoyed the show, please rate and review us on your favorite podcast platform. To learn more about our services, visit holisticheartcenters.com and subscribe to our YouTube channel. The link is in the show notes. See you next week.